So one final skill in sketching a quadratic given a particular function. So the last one is you can use the quadratic formula in order to work out some answers. And I'm going to give you another little formula that you could use as well. Now, it should be pointed out, when would you do this? Well, why would you not just factorize it and use intercept form or use turning point form? Well, when it's not convenient to do so. So the quadratic formula is a last-ditch effort, I suppose, to solve the problem. It's not that it's hard to do. It's just that with all the numbers floating about, it does get easier to make mistakes. But if you ever look at this problem, it's not easily factorizable into intercept form. I can't see two numbers that will multiply together to give me 1 that will add together to give me 5. So it fails the intercept test straight away. I can't do it easily. And for the completing the square, although I can do it, I've got an odd number in the middle, and it's going to give me 2.5, and it's a bit too much work. So instead, we're going to use the quadratic formula. So I'm going to show you a few things here. Let's just go straight through to the sketching, I suppose. Number one, the shape. Well, it's already in general form. I can see that x squared is positive, and so I know it's going to be a smiley graph. Okay, concave up. 2, the y-intercept. Well, the y-intercept is when x equals 0, so it's basically the value of c, right, when it's in general form. That goes, we're left with -1. So you don't have to do any calculations, just plonk it straight down. Number 3, the x-intercepts. The x-intercepts is where it gets hairy. Remember that the x-intercepts are when y is equal to 0. So we effectively have a polynomial, or really a quadratic trinomial, which is set equal to 0. And we've got the quadratic formula to determine what x is under those conditions. So we can go straight into that. We can go, well, a is equal to 1, b equals 5. You can do this bit in your head, but I quite like writing it down. And so we've got x is equal to negative b, so it's going to be -5, plus or minus the square root of b squared. I might even just do that straight up. B squared, 25, minus 4ac. 4 times 1 is 4, times -1 is +4. That's plus 9 all over 2a, which is just 2. So that gives me -5 plus or minus the square root of 34 all over 2. Okay, pretty ugly number. There's not much we can do. I can't think of any numbers that will go into 34 that are a perfect square, so I can't simplify this surd any further, I believe. We remember that we do have two values as a result of this. We've got -5 plus root 34 and -5 minus root 34. So I think what I would do really pragmatically is I'd probably just decimalize it, I think. If it said use exact form or something like that, you'd have to leave it with the square roots in and stuff. So again, this is not going to make for great telly, but I'm going straight to my calculator and I'm plugging in -5 plus root 34. And then I'm going to divide it by 2. If my calculator's right, that gives me 0.42 for one of them. And 0, of course. And the other one is -5 minus root 34. So -5 minus root 34 divided by 2. And that gives me -5.420. Okay, so that's the first 3 things done handily. The 4th thing is the turning point. I'm going to give you a little trick here. And the little trick is that the turning point, if you've got it in general form, can be worked out by x equals -b on 2a, like so. It works. I won't go through why it works, but you might note that the -b on 2a is part of the quadratic formula. And if you think about how these x-intercepts work, you might get a sense of why -5/2 would be the midpoint between these two x-intercepts. Maybe you can't, but it doesn't matter. If you can remember negative b on 2a, you're good to go. So that would be negative 5 on 2 times a, so it's negative 5 on 2. And for the y value then, that's the x coordinate. So the y coordinate would be negative 5 on 2 all squared plus 5 outside of negative 5 on 2 minus 1. You could probably use your calculator for this if you can. These numbers are pretty horrible to work out by hand, but I'll just quickly do it. 25 on 4 plus minus 1 at 5 times minus 5 is negative 25 on 2 minus 1. And that's equal to 25 minus 50 minus 4 all over 4, which is negative 29 if I haven't stuffed up on 4. So that's negative 29 on 4. Sorry, wrong way around. That's negative 5 on 2 and negative 29 on 4. Or if you like, negative 2.5 and 29 divided by 4. I could probably have done this in my head faster than I'm doing it here, is negative 7.25. Okay, so that's all the critical values worked out. So let's go straight into the drawing. So I've got my X and Y axes. Having a look at this, the turning point is probably the lowest point in the graph. It's minus 2.5, 7.25. So we'll put that around about here. Oops, got it around the wrong way again. Minus 2.5, minus 7.25. Then we've got the x-intercepts, or the y-intercept is minus 1. Might as well do that now. So the y-intercept is probably about here. The x-intercepts are 0.42 and negative 5.2. So 0.42 is going to be about here. And negative 5.2 is going to be about here, something like that. Okay, and then we can draw the graph in. Looking at all the critical points here, it looks like it should be a smiley graph according to the points. And looking here, my shape was a smiley, so that sort of confirms that I'm on the right track. And again, if you've got a piece of paper and a pencil, it's great if you just rotate the paper around for your graph. But I don't have that luxury, so here we go for dodgy-mology. Down it goes. And it's going to hit there and come back, and there is my that's the worst program I've ever done. Maybe it's not quite that bad. That's pretty ordinary. That's basically it. That's your parabola drawn, and you're good to go. So that's the third technique. So far we've got completing the square, intercept form, and sketching using the quadratic formula. You've got plenty of textbook exercises that you can do to practice these. In one final video, I'm going to summarize these three forms and explain when you might use each of those.